right, so looking at letter A then. Chloe, what'd you get? 6 is correct. So all we do, these are both like radicals. This is on page 129 in our student journal. We multiply the numbers under the radical. We get radical 36, and the square root of 36 is just going to be 6. Very good. Okay, what about on letter C then? Dan, what did you get when you multiplied these two? Okay. Kenzie, did you get this one? What did you get when you multiplied 27 and 3? Oh, Kenzie's not here, is she? Alexis then. Yeah. And the reason why, guys, is because 27 times 3 is going to give us 81. And so the fourth root of 81 is going to be 3. Now, you really didn't even have to multiply those two numbers, though. If you would have recognized that 27 is 9 times 3, and then we have this other 3, and so we have the fourth root of, and then 9 is 3 times 3, and we have the other 3s. As soon as we have 4 numbers that are alike, 1 comes out. Okay, and then what about letter D then? Chloe, what did you get? You didn't get to it? Can you tell me what 98 divided by 2 is? 49. Right, so I'd have the square root of 49, and what's that going to be? 7. Good. So what that means then is also 49 to the 1/2 would be 7, right? Because radical 49 means the same thing as 49 to the 1/2 power. All right, very good. Let's flip over now to page 130. If you ever get stuck on properties, just be aware that all the properties can be found here on page 130. We talked about this yesterday, how if we have like bases, and we're multiplying the two values, we'd add the exponents. If we have a power to a power, we multiply those exponents. When we have the power of a product, each one of those factors gets raised to the power. Negative exponents, to make them positive, we have to move them to the opposite spot. So if it's in the numerator, it goes to the denominator. Anything to the 0 power is 1. When we have a quotient of powers, then we have to keep the base, subtract the exponents. And when we have a quotient, we just do the power of both the numerator and the denominator. Both of those get raised to that power. All right, so now let's look at page 131. And let's start here with number 1. So on this problem then, if we have 2 to the 3rd times 3 to the 3rd and the negative 1/3, that just means that we can do our power to power. So I can say that I'm going to have 2, and then I multiply these. 3 times negative 1/3 is negative 1. And then 3 times negative 1/3 again is negative 1. So now we know if we have a negative exponent, it has to be 1 over 2, and now it's to the positive 1, and 3 is to the positive 1. And so that's going to be 1/6. Go ahead and look at number 2. On number 2, we have it to the 1st power. So when we have like bases and we're dividing, what do we do with the exponents? Subtract them. So it's going to be 1 minus negative 4/5. What is 1 minus negative 4/5? 9/5. It's minus a negative, so it's going to be a plus. So it's 1 4/5, so it's going to be 9/5. So it's going to be 10 to the 9/5. The other way you could have thought of this is that we have a 10 on the top. If I want to make this a positive exponent, I would take it to the top, and now it would be a positive exponent. What's the rule if we're multiplying? What do we do with the exponents? Add them. What's 1 plus 4/5? 9/5, right? See how it works that way too? Okay, let's come over here to number 4. If we can do something with it to simplify it, we should. So I first want to check, can I take a cube root of 3? I cannot, so I'm just going to have to leave it alone. Can we take the cube root of 27 though? What's the cube root of 27? 3 and then square it, and what do you get? 9. So this is going to be 9 right there. On the bottom, Evan, what's the cube root of 8? To the 4th. 16, good. So here's what we get for our answer. There's nothing else you can really do with it, but you might want to write it in radical form. In radical form, it would be 9, and then this is to the 1/3 power, so it would be the cube root of 3 over 16. That's the way that would look in radical form. When we have a quiz, I will tell you what form to write it in. This is called, actually we probably would even want to write it like this instead. But this is called rational exponent form, and this is called radical form. See how they're equivalent? The 9 stays the same, then we have 3 to the 1/3, which is the cube root of 3, and then 16. On number 5, find simplified expressions for the perimeter and the area. So we're told this is 10x to the 1/4. Notice how it's marked. All of the sides are the same. So this is going to be 10x to the 1/4. This is 10x to the 1/4. How do you find perimeter, guys? What do you do? Add up the sides, right? So if we have 10 of these, 10 of these, 10 of these, 10 of these, what are we going to get then for the perimeter? How many of them do we have? 40x to the 1/4. What's another way to write 40x to the 1/4, maybe in radical form? It'd be 40, and then what? What's our root? So it'd be the 40, the 4th root of x to the 1st, but we don't have to write it. So both of these would be correct. Rational exponent in radical form. How do we find the area of a figure, of a square, basically? Base times height. So I'm going to do base times height. So to multiply these, well, the 10s are alike, so I can just multiply those and I get 100. The x's, the bases are alike, so we add the exponents. What do we get, Lucy? Cobble, if we keep the base the same and add the exponents, what do you get if you add those exponents? Right, because it'll be to the 2/4, which is to the 1/2. So we have that. So 100 radical x would work as well. Rational exponent, radical form. Questions? What we did again was we had to add the exponents. So if we add 1/4 plus 1/4, that's 2/4, and she realized that would be 1/2. And those are equivalent. All right, flip over on the back now. So looking at number 6, here's something I want to show you. I'd like you to use your calculator as little as possible. To take a 6th root, we need to have 6 factors under here. If we do, then it can come out. I already know 25 is 5 times 5. Does anyone know what two numbers multiply to be 625? Yeah, 25 times 25. So 625 is 25 times 25. Well, 25 is 5 times 5, and that's a 5 times 5. And so count how many 5s we have. So what's the answer to this just going to be? 5. No calculator is necessary. On this one over here, we're going to skip 7. We're just going to do the evens from here on out. So I want the cube root of 25. So that's the cube root of 5 times 5. I can't take anything out. Here I have the cube root of 5 times 2. On the bottom, I have the cube root of 2. These are all cube roots. I need to have 3 alike to take one out. Do we have 3 alike? Yeah, we have 3 5s, so a 5 can come out. So all of these can come out as just a 5. So now what I'm left with is the cube root of 2 over the cube root of 2. Well, what's anything divided by itself? 1, right? So the answer is just going to be 5. Questions there? All right, take a look at number 10. I like to write this separately as the cube root of 5 over the cube root of 9. We need to have 3 factors to be able to take it out since we're taking a cube root. Right now we only have 3 times 3. Am I going to multiply this by the cube root of 3 or the cube root of 9? Which one, 3 or 9? 3, because I need to have 3 3's. I already have 2 3's. So if I just multiply by the cube root of 3 on top and on bottom, that's going to do it. On top I have the cube root of 15. On the bottom I really have the cube root of 27. But what is the cube root of 27? Just 3. And that's our whole goal, is we don't want to have a radical in the bottom, in the denominator. The reason for that, guys, is because when we're estimating values, it's really hard to divide by a radical. Let's take a very simple one. Let's say that we have 1 over radical 2. I already know radical 2 is about 1.4, but trying to figure out 1 divided by 1.4 is really hard to do. I can't really do that in my head. But watch if I rationalize this. I have 1 over radical 2, so I multiply by radical 2 over radical 2, and I get radical 2 over 2. Well, again, I know what radical 2 is. It's 1.4. 1.4 divided by 2, what is that? 0.7, right? So I can estimate this very easily. See, this is the same thing. That is the same thing, but that's really hard for me to estimate as 0.7, whereas this is easy to estimate. And that's the whole reason we rationalize the denominator. Before we had calculators, this would have been really hard to do, that kind, but this they could easily estimate. All right, number 12, again, we want to rationalize the denominator. We don't want to have a radical in the denominator. It's too hard to estimate. So what do we do in this case then? Gabby, do you remember? Right, what is that? Good. So we're going to multiply by that on top and on bottom. So on the top, we're going to have radical 2 minus radical 12. On the bottom, we do the first 1, outers, negative radical 6, inners, positive radical 6, last, minus radical 36. I want to simplify anything I can. Radical 2, nothing can be done. 12 is 4 times 3, so that's going to be 2 radical 3. On the bottom, negative radical 6 plus radical 6 is 0. Radical 36 is 6, so on the bottom I have 1 minus 6. So that's going to be 2 minus 2 radical 3 all over negative 5. Questions on that? Okay. Number 14. Pretty tough problem. I have 2, and then this is the 4th root of 1250. Here I have 5, and I have the 4th root of 32. See what I did? 2's on the outside. 1250, I've got the 4th root. 5 is on the outside. For the 32, I've got the 4th root. I need to break these down into something where I have 4 of a kind. What can 1250 be divided by? 250, can it? 250? So it's 250. How many 250s are in 1250? 5, right? So it's going to be 5 times 250. 250 is 25 times 10. This is 5 times 5. This is 5 times 2. So the complete factorization is going to be 5 times 5 times 5 times 5 times 2. I need 4 alike to take it out. So can I take out a 5 for that? Yeah. So 2 times 5 is 10, 4th root of 2. That's another name for that. Now I need to break this down. I need to have 4 factors that match. So 32 I know is 8 times 4. 8 is going to be 4 times 2. This is 2 times 2. 4 again is 2 times 2. So I know 2 times 2 times 2 times 2 times 2, 2 to the 5th, in other words, is 32. I need to have 4 that match, 4 factors, 1, 2, 3, 4. So that means a 2 is going to come out, but one of the 2's has to stay inside. And what is 10 4th root 2 minus 10 4th root 2? 0, correct. Questions on that? So we're always trying to simplify. We want to get things down as low as we can. Let's go ahead and look at 15 and maybe 16. We'll see how 15 goes. So, if we can simplify, we want to. 4th root of x, I can't do anything with it. Is there a 4th root of 81? What is it? 3. So that's going to be just 3. Then I would still have the 4th root of x on the inside. Nothing I can do there. On the bottom, I have the 4th root of 16. What's that? 2. And the 4th root of x to the 36. What's that going to be? X to the... Think about it, guys. I could write it as x to the 36 over 4, right? Because it's raised to the 36th power and the 4th root. What is 36 divided by 4? So it would be x to the 9th. Okay? So now we've got 3, and then we've got the 4th root of x squared on the top. What did we say that can be simplified to? The 4th root of x squared. It'd be x to the 2/4, so it'd be what? Radical x. So 3 radical x over 2x to the 9th is the best answer for that. You could also have 3x to the 1/2 over 2x to the 9th. That would be okay as well, means the same thing. All right. Let's go ahead and take a look at this next one. So, first of all, I have a 7 to the negative first. I'm going to want to bring that up to the top to make it a positive 7, or a positive exponent. Then I've got an x to the negative 3/2. I'm going to take that to the bottom to make it positive. So I wrote that, I wrote that, I wrote that. This radical x should stay where it is, so it's x to the 1/2. I'm going to write everything in with rational exponents. Y to the negative 1/2 should go to the top to make it a positive. This is already on the top. That's y to the 1/2. So I took care of those. This z stays on the bottom, and that z stays on the top. Now it's really not that bad to simplify once we have it this way. 21 times 7. What's that? 147, guys. So we took care of this. Now we have y to the 1/2 times y to the 1/2. Bases are alike, so add the exponents, and what do you get? Just 1, so it's y, right? Okay, here we've got x to the 3/2, x to the 1/2. Add those exponents. What's 3/2 plus 1/2? 2/2, which is, or 4/2 rather, which is just going to be 2. So we're going to have x squared on the bottom. What do we do with these two? What do we do when those bases are the same when we're dividing? What do we do with the exponents? Subtract. So it's going to be 5/2 minus 1, which is 5/2 minus 2/2. So what's that going to be? 3/2. And it's bigger on the top, so it's going to stay on the top. That's one way I could write it. See if you understand this way. 147y z radical z over x squared. See why this will be z radical z if it's z to the 3/2? Because it's the square root of z to the 3rd. So we'd have a pair of z's, so 1 would come out. That pair would come out as 1 and 1 would stay inside. Does that make sense? All right. So there we go. There's the best answer there. So some pretty challenging problems. You guys did well. Okay, so hopefully you did the worksheet and hopefully you checked your answers on Canvas. They were on the calendar. Did you guys check or no? Did it? Oh, I'm not.